Yeah, okay. So last time we talked about causation versus association. We said that causation was something that related two variables through a cause and effect link, whereas association just allowed me to say that two given variables follow a given trend, but it doesn't necessarily allow me to say which one was responsible for the other one, either growing or shrinking, right? And what we said is that depending on the type of data that we collect, we're going to be able to show either association or causation. So if we want to show causation, we can show that using experiments, because that allows us to control just one variable that is different between two given groups. Whereas if I have observational studies, I am only able to show association because I don't necessarily have control over the variable that is changing from one group to another. In the homework, you had to look at in the homework, you had to look at 7 given scenarios and determine whether you had to use an experiment or an observation. Okay, so I'm just going to make little stamps like this. So for the first example, you had to determine if people that live near highways were more likely to have asthma than people that don't live near highways. What type of study should I use in this case?
Observation.
An observation, why is that?
Because you can't give people asthma.
Yes, ideally you won't be giving people asthma, and so that means, well, it's unethical to expose people to risk, and so you are going to do an observational study. Oops, that's the opposite of what I'm doing here. You're going to do an observational study due to ethics. Then you have cutting the line and versus, like, are adults or teenagers more likely to react when somebody cuts the line? In this case, what do you think we would have to do?
I said observation.
Observation, why?
Because I don't know, I feel like if you're in a study, like, people aren't gonna react. Like,
okay, so there's the aspect of the subjects not necessarily knowing that you're observing them. That's true, but it is also possible to do experiments in which you have the subjects not know that they're being
also
studied.
Like, how would you make a control group kind of thing?
Exactly. I think that's the big thing over here. If we're trying to study the effect of being an adult or a teenager on cutting the line, you can't really control which group is going to be an adult and which group is going to be a teenager, right? So that means you can't just introduce this property and create a group of adults and a group of teenagers by your own choosing and randomizing everything else. There might be some other aspects that are affecting whether they speak out or not that might also have to do with them being an adult or a teenager. So there's no other choice but to do an observational study over here. Yes, Alex.
Sorry, just for the cutting the line one, you could do experiment too, because if, let's say, you go to like a park, you just go through the same ride like 5 days in a row, and you cut in front of the line, see how they react, and then you get out of the line after they reacted, right?
Okay. So that is true, but the thing is that even though that is an experiment, the idea is that you are not actually choosing the groups at random. Your treatment, there's no treatment group and no control group, because you can't control for age, right? The age is just a trait of the people that you're studying, and so you can't control for that fact. So you won't necessarily be able to show that it is because you're an adult or because you're a teenager that you spoke out.
All right.
Okay. Oops. Okay. Next thing. So being alone versus stress. Should I do an experiment or an observational study? Carolyn.
Me was for the other one, the second one. Can you choose your population? Like, can you choose the people, like teenagers between 13 and 19, and then adults like 20 plus?
You could, but even then, so that would still be an observational study, right? Because you're not introducing a treatment.
Okay, so you like a criteria. You need a control group and an experimental group. Like, you can't do.
Yes. Yeah, so you have to do a treatment because that's the only way that you can actually control, you know, like which people have the property because it's been randomly assigned to them. And by randomly assigning, that's the only way that you can really say, okay, that was the one defining factor that caused them to react or to have like a certain disease or whatever it is.
Okay, thank you.
Yes, Alex.
I just didn't understand why it wasn't experimental. Like, how come it wouldn't work?
Okay, so the whole point of having an experiment is to randomly apply a certain treatment to a given group, right? And so if you're, like in this case, you're trying to look at whether being an adult or a teenager causes you to react more when somebody cuts in line, right?
Yeah.
Now, it's not like you can take two groups and say, okay, you're the adults and you're the teenagers, right? That cannot be randomly assigned. What you are doing is you are taking people that already have these characteristics and then separating them. Now, by having people that are adults or teenagers and measuring their differences, you are observing the differences that they have, but you can't necessarily say that the difference in the reaction is caused by the fact that they have a difference in ages. Because maybe, you know, like the fact that they have different ages comes with another array of differences between these two populations. Maybe, you know, the adults are reacting less, not because they're less reactive, but because, I don't know, they have more experience or whatever it is, or they react more because they are more subject to stress or something like that. But the defining factor is not the age, it might be something else that is associated with age. So you can't distinguish exactly the age or the fact of being an adult versus a teenager to be the cause of the reaction once somebody cuts in line.
But it does work for observation, like that same thing?
Yes, so it works for observation because then you can say, okay, there seems to be an association between the age and the reaction, but I can't necessarily know if that's the only reason that that reaction is occurring in that way.
Okay, thanks.
Okay. Then what about being alone versus being stressed? How do you think you would do this? Observation or experiment? Oh, come on, we were on such a good streak.
Observation.
Observation. Why observation?
Because you're not like applying like a stimulus, you're just, I don't know, they're in their natural habitat.
Okay, so you're looking at them in the natural habitat. That's a possibility. Does anybody have anything else to say about that?
I said experiment.
Why?
Because you can't really like see somebody's stress level just by like observing them. So they should be like run tests to see how stressed they are.
Okay, so you would have to run tests, but how would you perform an experiment if you wanted to determine if being alone causes people to be more or less stressed? How do you think you would do that?
Well, have a group of people live like by themselves and a group like together, and
Okay,
then
so
just test the overall stress.
yeah, so you
Social
could do something
distancing.
like that. Social distancing, for example, this is what we call a natural experiment. So what you're doing is you're selecting a group and just at random, you assign some people to live alone, some people to stay at their houses or to live on their own, and then you measure their stress level. There's one caveat in this case, one warning that we have to put, and is that if this becomes dangerous at any point during the experiment would have to stop, right? If the person is being exposed to actual severe anxiety or feelings of depression or stuff like that, then the experiment would have to stop, because experiments, of course, cannot put people at risk unless, the only option to do this as an experiment is if we can make sure that people are not at risk. Kayla, was that what you were going to ask about? I lost Kayla. Okay.
I think you're muted.
Oh, there we go.
Okay, there you go.
I don't understand how you could do it. You could not do an experiment on like asthma, like causing asthma and stuff. But you could like cause someone to be stressed. Like, isn't that?
I think that's a fair concern, and I do agree that some of the things are like, it's not always black and white, right? So all that I'm saying here is, in this case, an experiment seems like it's feasible, but of course it wouldn't have to be up to a point at which people are being like extremely affected by it. So you would have to set up some kind of threshold after which you say, okay, you know what, this is not working. We need to remove this person from the experiment because it has a very, very extreme effect on stress. Now, like we're saying here, we could do an experiment based on the assumption that this is not going to have such dramatic effect on the well-being of a person.
Okay.
Yep. All right. What about, so there's like the possibility that this is an observational study if there's like populations at risk or anything like that. So I'm just going to put that in brackets and an asterisk over here just to say, okay, we need to be careful about extreme effects that a study might have. Then what about the sex of a person and being late to class? According to you, experiment or observation?
Observation.
Observation. There's nothing that we can control. We can't just assign one group to be women and one group to be male. We can say one of the two, but then we can't conclude causality. There's maybe other factors that are being worked into whether somebody is late at class or not. Then radiation effects after 2 days, I think was the setup. Experiment or observation?
Experiment.
Observation.
Ooh, somebody wants to play. I would say observation because radiation already has been shown to have poor effects on people's health, and so that's not something that you want to expose people to. Now, if you're looking at different levels of radiation or very minimal exposure, then the discussion might be a little bit different. But I'm going to put radiation as like the main possibility that we have here, possibly with an asterisk over here in case there's some very big subtleties and the experiment would have to be very controlled on its own. Now, what about video games and violence?
Experiment.
I say experiment.
Okay, so I agree with that. I would say experiment in this case as well, because, well, we don't expect that automatically somebody will be playing a game and then go out and, like punch a bunch of people. But you can measure in general, like maybe if I don't know, children were exposed to violent games for a year and then another set of children was not exposed to violent games for that same amount of time, then you can measure the consequences a couple of years later and see what happens. Okay, so in this case, you can control for the group that is going to play versus not play video games, and that should be the control group versus treatment group. Something that is really important in this case is that these, like the whole sample that I'm going to study should be chosen first, and then I should randomize them into one group or another, right? Because if I just look at the people that played violent games versus the people that didn't play violent games, then I'm working a bunch of other things into the possible explanations for violence afterward, right? So maybe, I don't know, children that were less under the supervision of their parents were more likely to have to play violent games and then to be exposed to violence. I'm saying just any random thing. But then this would be an observational study, right? So what we need to be careful of is first choosing the people that we're going to study, then dividing them into groups, and then assigning a treatment to each one of those groups at random, okay? So that's like the key part over here. And for study number 7, should it be, what am I saying? Experiment or observation?
Experiment.
Experiment, why?
Well, nobody's going to be just randomly testing rocket and fuel mixes, so you have to just do it yourself.
Agreed. Anything else?
I don't know.
Did anyone else answer something different?
I said neither because we don't really have the resources to get anywhere close.
Okay, so I would say...
Isn't it observation because it's not feasible?
It's observation because it's not feasible? Okay, so I have a lot of answers. I have experiment, I have observation, I have neither. I would say, personally, observation, because you can look at what has happened in space with different rocket and fuel combinations, but that's all that you can do, right? There's no, I mean, you can experiment, but then you would have to spend all the resources of all of these space agencies in the world, and that's probably not going to be that feasible. Whereas what you can do is see at different combinations that there were, how they performed in space, what speeds they reached, and then see which ones seem to be a better fit if we want to reach the speed of light. Does everybody understand that?
Yep.
Yep. Okay. So I'm going to say observation over here, and that's for concerns of feasibility and cost efficiency. Okay. So those are also things that we need to consider. All right, so how's everyone doing? Show of hands, virtual hands, if you understand everything over here. Okay, that's good. I have a full set of virtual hands. Very good. Oops. All right. So now what I'm going to do is start on a discussion that we began last time, which was about confounding factors. So confounding factors, I think I defined last time as variables that might be associated or causing two variables, and in such a way that those two other variables seem to be linked to one another. Right? So we said it's one variable, a confounding factor is one variable that seems to be affecting two variables at the same time in such a way that those two other variables seem to be linked. So we talked about GPA and friends. Let me just see, because I think there might be hands up and I'm not looking at them. Okay, everybody hands down unless you have a question. I still have Johanna, Alexi, and Oria with their hands up. Okay, so we said last time that there was GPA. The GPA seemed to be associated with number of friends. Right? And one of the things that we said is, okay, well, there's not necessarily one single variable that, a direct link that says, maybe if I have GPA, a high GPA, I'm going to have more friends. There's no reason why necessarily if you have better grades, you would have more friends. Nor is there necessarily a link between having more friends and then as a consequence having a higher GPA, right? It's not necessarily because you have more friends that you have a higher GPA. What we said is maybe there's the possibility that there's a third variable that is affecting both the GPA and the number of friends at the same time. And that variable that I proposed, which is not necessarily the one that is right or the only one that is right, could be confidence. Right? And what we said is confidence might cause GPA to be higher, and it might cause the number of friends to be higher. And this is actually a causal effect. And then that means that there is no causal effect between these two. Instead, there seems to be a link between these two variables. Okay? Now, what I want you to try to answer is, I have another set of variables. Okay, so I'm just going to define. So the definition of a confounding factor is confounding factors are variables that are related to both the explanatory variable and the response variable in an observational study. Okay, so confounding factors are variables that are related to both the explanatory variable and the response variable in an observational study. This is confounding factors. Now, what are explanatory variables and response variables? Those are the variables that we see, so explanatory variable and response variable. So these are the ones that seem like one of them is changing and then the other one seems to be changing as well. In an observational study, because we can't show causality, we can show association, but often we have a tendency to try to explain one variable with respect to the other one. We can't say that they are related to causality, but we can say that one of them seems to be an explanation of why the other one seems to be increasing or decreasing. Okay, it doesn't necessarily mean that there's causality between the two of them, but that one of them might be a good indicator for why the other one is changing. Okay, does everybody understand that, more or less?
Yes.
Yeah.
Okay, good. So what I'm going to ask you now is, I have a statement over here. I want you to try to determine what the two variables are and what the confounding factor is. So same type of drawing that I did at the top over here. So where you have one variable that's affecting two of them that seem to be linked. I want you to try to do the same based on the following statement. Research shows that an increase in the number of umbrellas sold leads to a decrease in crime rates. Okay, so you'll have maybe 1 minute to think about the two variables that are being linked here, and then if there seems to be a confounding factor that could explain both of these. Okay, so does anybody have an idea of first what the two variables that are being linked here are? What are the two variables?
Umbrellas and crime rates.
Okay, so umbrella sales and crime rates, right? So umbrellas. Oops. Umbrellas and crime rates. And according to this headline, the increasing number of umbrellas sold leads to a decrease in crime rate. So that means that the number of umbrellas causes a decrease in the crime rate. Now, does this seem like a reasonable conclusion to draw?
No.
Or does this seem like a logical thing that would happen?
No.
Not really.
Okay, so we shouldn't try to necessarily give an explanation of why this would be true or not, because chances are there's not an actual causal link between the two of them, and rather this is an association between two variables, right? So the idea here is that this is an association between two variables and not a causal link between the two. Now, if this is a link, that means that maybe there is a confounding factor that I can find that would be responsible for both the number of umbrellas growing and the decrease in the crime rate. Anybody?
I feel like it's like the weather, because when it's like not nice outside, people don't want to like commit crimes outside. I don't know.
Yeah, so you have, okay, so it seems like if it rains, okay, if it rains, then there's going to be more umbrellas that are sold. And also, if it rains, there's going to be fewer people outside, which might cause crime rates to drop, right? So that means that it looks like rain, oops, might be the reason for both the sales of umbrellas to go up and the crime rates to go down. Does that make sense for everyone?
Yeah.
Yes.
Right, so this is a fairly easy one to look at. It seems like, you know, like the finding the confounding factor is not too bad in this case. Now, whoops, before, what am I doing? I'm going to share another screen. All right, so I have another, here you go. Here you go. So this is another thing. It seems like in this figure, I have, does everybody see my mouse or no? Doesn't look like you see my mouse.
Yeah, we see it.
Yeah, you see it? Okay, okay, okay. So you have on the x-axis chocolate consumption per capita, and on the y-axis number of Nobel laureates per 10 million people. Okay, so amount of chocolate that people consume in a given country versus the number of Nobel Prizes that people in that country have. Okay. And what we have over here is that it seems that there is a positive association between the two, right? It looks like the more chocolate people consume in a given country, the more Nobel Prizes people are going to earn in this country. Now, according to you, is this a causal link? Do you think chocolate makes people smarter?
Yes.
No.
I wish. I mean, I don't know if about you, but I wish it made me smarter. If eating more chocolate means that I'm going to earn a Nobel Prize, that would be a pretty sweet deal. Oh, no pun intended. Huh?
We'd all be fat though.
Well, yeah, I guess the other poor consequences, but could be dark chocolate, and it's not that bad.
Fair enough. Fair enough.
All right, so of course, there's no causal relationship. There's no reason why we should believe that chocolate consumption might lead to us earning Nobels. According to you, though, what might be a confounding factor in this case? What if I told you chocolate is not a very cheap product to either produce or consume? What do you think that has to do with anything?
Economic, like, comfort of the citizens, maybe? I don't know.
Yeah, that's a possibility, right? So it looks like maybe countries in which people are more likely to consume and therefore spend money on chocolate might also be the countries that have like a better financial status that allows them to have a better educational system and therefore winning more Nobel Prizes. Does that make sense for everyone?
Yes.
More or less. It might be far-fetched, but it's a possibility, okay? And sometimes, you know, we might want to look at the other variables that we have if we want to kind of uncover what's behind. It's not necessarily this, but it might be a possibility, and we need to take that into account. Now, it's not always that easy to identify what the confounding factor is going to be. Even in this case, you know, we have more or less of an idea, but it's not really that clear whether this is the actual confounding factor. Now, what about if I talk to you about this correlation over here? Whoops, what's happening? Oh, there you go. So this is the number of people who drowned by falling into a swimming pool. And there's a correlation between that and the number of films that Nicolas Cage appeared in a given year. So you can see in years that there were more people that drowned, there were more Nicolas Cage movies. According to you, is there any reason why these two should be correlated?
Not at all.
No.
No, right? Chances are, okay, there's a couple of possibilities. Maybe there's like this really complex chain of confounding factors, one after the other, hundreds and hundreds of confounding factors that actually make these two be linked to one another. But most likely what happens is that these two things just happen to have the same trend. There's a couple of points, they seem to follow the same kind of trend, and it doesn't necessarily mean that there's either any association between them or any causal effect between them. Okay, so it's really important that when you see a causal effect or even a link between two given variables that is published in some kind of paper or something like that, you think twice about believing that there's a reason for that link or that there is a link at all. Okay, it's not always the case. You can actually explore this a little bit more if you go into the website. So I'm going to go back to the whiteboard. So you can go into the website, not right now, please, although I can't control it. There's spuriouscorrelations.com, and there's, I think that's the website. If not, then you can just Google spurious correlations, and you'll see a bunch of different correlations that have nothing to do with one another. It's just coincidences. Okay, so that's what I want you to think about, the fact that it's not necessarily because you see an association between two variables that they have to necessarily cause one another. Raise your hand if you have understood everything today. So you can go to your team, to the team for the class. I posted a link to YouTube. And the clip that you have in there, yeah, hopefully. Yeah, the clip that you have there is a link to a Family Feud episode. Okay, so I want you to watch it. It's 5 minutes. I'll give you 7 for the, looking for it on Teams and everything. So I want you to look at that. Yeah, what am I doing here? Okay, at that episode, and that you answer the 4 questions that are displayed on the board. Okay, so that is, how many people were surveyed? Do we know who these people are? How many survey questions were there in this survey? And when the host says, survey says, what does this mean? Okay, you have 5 minutes. Think of it as a little break and just answer these 4 questions. Maybe you can compete as you go.
These guys really just won 20K.
Yes, they did. Okay, so once you're done watching the video, answering the questions, please raise your hand virtually. That will help me. Okay. I have 10 people with raised hands. Please keep your hand up if you finish watching the video. All right. Okay, so we can discuss the answers now. We have Family Feud. Who had seen Family Feud before?
Me.
I have.
Yeah.
Same.
Everyone, I think.
Good, hopefully. Yeah, I don't know, I think. All right, so everybody knows the concept of Family Feud. You have questions, and if you can find the most popular questions, then you win some money. And in the last round, if you find a lot of the very, very right answers, then you earn $20,000 really fast. So the first thing is, how many people are surveyed, at least for that round of Family Feud?
200.
Everyone, 200?
But how did he get 208 then?
That's
Sorry?
true.
No, because he said 200, but the total was 208. So I don't know.
Don't we not know?
Okay, anybody
Yeah,
else?
you can go over the 200. That's true.
Yeah, I'm saying we don't know because he like got.
No,
Okay, who
because
says they don't know?
200 people. No, because 200 people answered like all 5 of the questions. So in total, you can still get over 200 if you get like 30% like on multiple times, right?
I don't know.
No, dude, I don't think that's correct.
Yeah, no.
That makes
They
sense.
didn't say 200 anywhere, right?
Yeah, they
I
didn't
think
say
it's
like
we don't know how many people were surveyed.
Okay.
You just have to beat 200.
Anybody that has ever watched Family Feud, how many people do they survey in each one of the rounds?
100.
100. So there are 100 people that are surveyed. Now, why did the totals add up to more than 200? That's because you had, for each one of them, answers that were maybe 30, 60, and so on. And these stacked up, but they were answers to different questions, right? So you can have the same person answer different things to different questions. And so the same result can be counted several times. Does everybody understand that?
Yeah.
Yeah. Okay, so that's why we can have a result that is larger than 200. Do we know who these people are?
No.
No, I agree with that. We don't know who they are. We don't know how they were chosen. We don't know if they called them, if they saw them on the street. We have no clue. How many survey questions were there?
5.
5 questions, easy questions. And then the last thing is, when the host says, survey says, so he says, survey says 64. What does that number mean? What does it mean to say survey says 64 or 30?
It's the number of people who agreed with the answer.
The number of people who agreed with the answer, the number of people who gave that answer, not only agreed with the answer, because this is not like he proposed those options. These people answered that specifically. Okay, so this means that that number of people gave the specific answer that the contestant gave. Everybody okay with this? Does anybody have any questions about this?
Nope.
All right. So in the next part, what we're going to do is talk about surveys and how we can use surveys in order to collect data. Okay, so we're going to have just. Okay, so we have surveys over here. Can anybody tell me what a survey is?
It's when you ask people questions.
It's when you ask people questions. This is a type of study. Would you say that a survey is an experiment or an observational study?
Observational study.
An observational study, right? Because you are not applying any kind of treatment on the people that you're asking questions to. So a survey, oops, I need to write here. A survey is a data collection method where the data is self-reported. What does it mean, self-reported?
Because they can answer the question however they want.
Yes, exactly. So each person answers the question themselves, right? So it's not data that is being collected by somebody like this that is looking at people, but rather people that are answering questions themselves, right? So meaning the participants answer the questions themselves. Okay. So surveys have several elements. So surveys are composed of. The first thing is that in order to have a survey, you need a questionnaire. I have James, Gemma, Katrina, and Kyle with their hands up. Unless you have a question, can you please put them down so that I don't get. Okay. The next thing that we need in order for a survey to be good is a representative sample of the population of interest. And the questionnaire, I'm just going to put that as a bracket over here, has to include very carefully worded questions. Okay. All right, so this is what a survey is. This is how it's composed. So either you need to have a questionnaire in which the questions have to be really, really well thought about, and a representative sample of the population of interest. We'll talk a little bit about samples and populations in just a second. So in order to have a good survey, you need to have good questions. And the questions that you can ask in a survey can have different types, right? So there's different types of questions that you can ask in a survey. I think that's the next slide that I had prepared. Is it? Yeah, so you have the types of survey questions. Survey question can be open-ended or closed-ended. So an open-ended question is a question in which the participant is not being given the choice among predetermined options. So options that the person that is conducting the survey chose in advance. Whereas open-ended questions are questions in which the person that's answering can give any answer that they want, however they want it. Okay. So closed-ended means the people that are doing the study are providing the options and then the other person has to choose, whereas open-ended means there's just a question and the person is free to answer whatever they want. Now, there's a couple of options. The first thing is a multiple choice question. According to you, a multiple choice question, is it open-ended or closed-ended? Sorry?
Closed-ended.
Closed-ended, right? Because you can only answer the only answers that you can give are the ones that the author provides in advance. Then you can have questions of the form, write a paragraph explaining something. According to you, is this open-ended or closed-ended?
Open-ended.
Open-ended, very easy, yes. Then you can have yes or no questions. Are these open-ended or closed-ended?
Closed-ended.
Closed, because there's no other options. Then you can have comments, which are open-ended or closed-ended?
Open.
Open-ended. Then you have scale questions. So that means, for example, on a scale from 1 to 5, rate something. Is this open-ended or closed-ended?
Closed.
Closed-ended, right? It's 1, 2, 3, 4, or 5. Those are your options. That's where it stops. Then you have write a sentence describing something. That is
Open-ended.
Open-ended. And then the last option over here is check a box in order to answer a question. Is this open-ended or closed-ended?
Closed.
Closed-ended, because the boxes are predetermined by the author, and the person that is answering the survey is only free to answer the questions in the way that the author has created. All right, so what I'm going to do now is just talk about one possible example on how to create survey questions. You're going to be creating your own survey questions at the end of today. So here we go. We have that a sociologist wants to study the following research question. What are households in Montreal? He will be creating a 3-question survey. It's not a very long survey. To be administered to high school students. So the subjects of the study are going to be high school students, and then we're going to try to figure out what households or how households are composed in Montreal. The first thing that I want to ask you is, what are some elements that we could be interested in if we wanted to study this? Anyone?
Like if they're a family of 3 or 4.
Okay, so we can think about the size of the family.
Yeah.
What else?
Oh, if they share, like if the work is shared or like divided between.
Okay, so who
all of them.
works?
Yeah.
Anything else? If you're shy to talk out loud, you can write on the chat.
Who cooks?
Who cooks? Now, also a household, it's not necessarily just, does not necessarily have the same definition for everyone, right? So you might have some people that live with just their parents and their siblings, but you might have people that live with aunts and uncles or grandparents, or maybe like a family friend or cousins, whatever it is, right? So you can look at the composition of the household, right? Who lives together, and a bunch of other things like that. Does that make sense for everyone? Yeah, so you can ask a bunch of things depending on what interests you. Now, I am going to create 3 questions for this study, and I'm going to I'm going to create 3 statistical questions for this study. For each one of them, I'm going to create 2 survey questions that are the same, but are formulated in different ways. And we're going to see how we can formulate questions in different ways. So for the sake of this subject, I'm going to have 3 statistical questions. So let me just, oops, that was backwards. 3 statistical questions to be linked with 3 survey questions. Okay. So my first statistical question is going to relate to the size of the household. So what is the typical size of a household in Montreal? Right, that's my first statistical question. And I'm going to phrase the question for this in 2 ways. First, I'm going to create a multiple choice question. Okay, And my multiple choice question is going to be, how many people live in your household? But I'm only going to give the following options, which are 1, 2, 3, 4, 5 people or more. Right? So 1, 2, 3, 4 people or 5 or more. Okay. And so what this means is I have now just these 5 options, and the person that is answering can only choose between these options. Now here I'm going to put a big warning, which is that when you have a multiple choice question, you need to make sure that all possible should cover all possible cases, right? So that means you shouldn't have a multiple choice question, for example, that is, how many people live in your household? 1, 2, 3, 4, or 5 people. Because what happens there? If your household has 6 people, you don't have a box to tick, right? And if you don't have an option that covers your case, that means that you're going to be missing information or having wrong information given in your survey. So you need to make sure that all of the possible cases are covered by your choices. Questions about this? Yes, Carolyn.
I find the question kind of confusing because when you say how many people live in your household, do you include yourself when you answer?
Do you include? Okay, so that's a very good point actually. You could say how many people live in your household and specify including you. So you're just bettered my question. That's great. So including yourself. Okay, and so this is actually a very good point in that the question should be very clear about whether, like, what is the answer that you're expecting. And the second question is, for this one I did have it, so it was excluding yourself, how many people live in your household? Right, so this is a different type of question, not because the question is different in essence, but because in this case, I'm just going to leave a space for people to answer, right? So that what that means is now it's not a multiple choice question. It doesn't fall within a category. It will actually give me a number, okay? So then people can answer 0, 1, 2, 3, 4, or however many people aside from them live in the same household. Does this make sense for everybody? Questions? All right. So second question, statistical question. What is the typical composition of a household in Montreal? So basically that means who is in the household in Montreal. So like, do people live with their parents, with their children, with their, like, whatever it is, right? So of course we need to keep in mind that this is a survey that is being administered to high school students. So in formulating the questions, that's something that we're going to have to consider. So one option is to say, write a paragraph, right? So describe who lives with you, right? And so that means that a person would be given a certain box in which they would answer this question, who lives with you, and that's it. Then another option is, which of the following people live with you? Check all that apply. So this is a checkbox question, and in this case, you would have different possibilities, right? So for example, mother, father, siblings, son, a son or a daughter, grandmother, grandparent, basically grandfather, grandmother, aunt or uncle, and then because this is check boxes, I don't want necessarily people to enter their own possibilities. So I'm just going to try to cover all the possible other cases. So other extended family members, or other persons to whom you are not related. right? So in that case, we are considering all of the possible cases, and that's pretty much on. Actually, I'm going to put right before here, yeah, step parent and step siblings as well. Forgot about that. Siblings. There you go. Does this make sense for everybody? Already muted their microphones or left the room?
Yes.
Okay, good. Thank you. All right. So according to you, if you were to conduct a study, a statistical study, which of these two questions would be easier to solve? Would be easier to use data from? The first or the second version of the question?
The second.
The second, right? So in general, if we are going to try to do a study using statistical analysis, closed-ended questions, for the most part, not always, but for the most part, are going to be a little bit easier to deal with, right? Because they allow me for a little bit more control over the results that people, over the answers that people can give. And then the third question that I can ask here, just an example, would be, are single parent families common in Montreal? So one possibility over here is a yes or no question, which would be, do you live with both of your parents in the same household? Right, so this would be a yes or no question. And it is an option in order to determine whether single parent families are common in Montreal, but it's a little bit off target, right? Because you might be a part of a family in which you don't live with both of your parents, you live with a step parent, but still it's not a single family, a single parent family, right? So again, this is a close-ended question that might be useful because it's easy to deal with, but it's not necessarily targeting the question that I'm trying to answer. Or you can write a paragraph and then like explain what the relationship between your parents is. What the relation between your parents is, and so on like that. And that gives a lot more flexibility for people to answer specifically to the experiences that they live in, whether that be that they have step parents, that their parents are single parents, that maybe like there's some other situation there. So it allows for a little bit more flexibility. Does this make sense for everyone?
Yes.
Okay, good. Thank you. So in the next part, okay, so this is about just creating survey questions. At the end of class today, you're going to be creating your own survey question. And you're going to have to keep in mind that a survey can only really be as good as these things. So a survey is only as good as the questions it's asking. So the questions like as its question, like its questions, and as good as the sample that answers the questions. Right? So if your sample is not good, then whatever results you get from your survey are not going to be that applicable or that good. All right, so this is about survey questions. Again, I'm pausing here for a second. Keep that in mind for the end of class. And we're going to talk just a little bit about samples. Okay, so how do I make sure that a sample is good? So we have the following statement, which says, for today's teens, friendships can start digitally. 57% of teens have met new friends online, and the margin of error is plus or minus 3.7 percentage points. We will elaborate on this statement later on in class. So like the margin of error, we will define that, I think, in the next lab. And And then social media and online gameplay are the most common digital venues for meeting times. So this is a study that was conducted by a research company on teens between the ages of 13 and 17 years old. And there were 1,060 teens that were surveyed over here. So I'm going to ask you a couple of questions, and as you've been doing, which I really appreciate, you can just answer into the mic and then we can discuss, and then if there's a lot of people talking, we'll take turns, but for now, just answer the question. So the first thing that I want to ask is, the report says that 57% of the teens have met new friends online, right? So that's not a question. This is just like repeating. Now, according to you, so because there were 1,060 teens that were surveyed, my question is, how many do you think met friends online? So if 1,060 teens were surveyed, how many of them had actually met friends online?
604.
604. Why is that?
Because 57% of 1,060 is that.
Yes, exactly. So if you do 0.57 of sorry, that's not a U, of 1,060, okay, 57% of 1,060 is going to be 604.2, and so that means that, so 0.57 times 1,060 is equal to 604.2, which means that about 604 of the people actually met friends online. Does everybody know how to, is there any questions about how this number of 604 was found? Or does everybody understand? Silence means everybody understands. Okay. Then.
Yes.
Do you think that 57% of the students in our class have met friends online? Yes or no, and why?
I'd guess no.
Why?
Well, I mean, I personally haven't met friends online, so I'm guessing people in the class have the same experience.
Okay,
I
so
disagree.
you're assuming that that people will resemble you. Who disagreed?
Me.
Okay, so can you explain why you disagree?
Well, same as him, my experience is different. I have made friends online, like that I'm still friends with to this day. So I think that's totally a possibility for people to meet people online and to be homies.
I just took our class number and multiplied it by the 57%.
Okay, and
I got 22.8. So no, my answer is no. I don't think everyone in our class has met people online.
Oh, but I'm not asking about everybody. I'm asking about 57%. Do you think 57% of the students in our class will have met friends online?
Yes.
Yes? Okay. There's a question in the chat.
No, because it's a much larger scale. Like you're looking at 1,060 teens. Like in our class, there's only like 40 people tops. So like the chances are like different, I guess, like the percentages.
Okay. So in the chat, Erin says it's also a different age category. So there's also that we can take into account. So the survey was distributed to teenagers between the ages of 13 and 17 years old. So it's not going to be exactly the same. There's the fact that our class is smaller. So that means probably we're not going to get exactly 57%. Carolyn, there's another answer?
Well, it says there's a 3.7 percentage point, so we're probably close to 57%.
Okay, so chances are that we are close to 57%. Of course, that's assuming that the sample that they chose is pretty representative of teenagers in North America, and assuming that our class is a pretty good representation of, it's pretty representative of teenagers in North America. So here's what we're going to do. Anyone, okay, so everybody lower your hand. Everyone, okay. Now, everybody that has met
Wait,
friends
Miss,
online, yeah?
how do you raise your hand and bring it down?
Okay, so you're going to go to participants. There should be either at the bottom or at the top something that says participants.
Yeah.
And there's a new window that appears, and at the bottom right there, you should have an option to raise hands.
All right, thank you.
Okay, so everybody that has met friends online, please raise your hand. Okay, now I need to count. Okay, last chance. All right, I'm gonna count, so give me a second. Okay. All right, so do we think, okay, so now you can lower your hand. To the question, do we think that 57% of students in our class have met friends online? I would say most likely, not exactly 57%, but maybe assuming that both the class and the sample were representative of teenagers in North America, it seems like possibly it could be close to that number, right? The next thing that I'm gonna ask is, what percentage of students in our class have met friends online while being a teenager, or online, let's say just that. Okay, so today in class, there are 38 people that made it to class. And of those 38, 24 said yes.
Um, 63.15%.
63, yeah, so that means that 24 over 38 is equal to 63.16% because it's 1578. Right, so now we have 63% of people in class have met friends online, right? Now, this is more or less close to 57%, not necessarily exactly equal, but that's not necessarily a big problem, right? So we have a value that is more or less close. The next question that I want to ask is, oh, I lost my stuff. Okay. Do you think 63.16 is closer or further away from the actual percentage for all of Canadian teenagers? So, like, which one do you think would be a better estimator? 57% or 63%?
Probably closer.
Which one?
57.
57%. Why 57%?
Because it's a larger group.
It's a larger group, so that's a very good point. So you have a larger sample, which means that it might get closer to the actual value. What other reason could be behind there being what other reason could there be behind 57 being a better estimate? Why could we not trust the estimate of 63.16 that much? Aside from the size of the sample.
we're all kind of from one more specific area.
Give me a second. Okay, I'm sorry, I just had an accident. So yeah, so okay, so you have 63%. What other possibility could be behind 63% being further away from the actual proportion in Canada? Anyone? Why is 57% a better estimate?
Maybe because we live in a population where a lot of people use technology, and if we were to look at other provinces, they might use less, like people up north.
Okay, so
they've
there
met less
might be
people.
there might be the possibility that, you know, other people have different experiences, maybe different uses of technology, and specifically, you know, in our class, we have probably what's a very homogeneous population, right? So all of you more or less live toward the west of Montreal. You all go to the same college, have had similar experiences growing up, and so chances are you're a very similar group and not necessarily representative of all the population of teenagers in Canada. Does that make sense for everyone? Somebody unmute their thing to say yes.
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 Okay, thank you. Okay, good. So the next thing that I want to ask is that suppose that our sample were actually pretty good and representative of what we expect to do, to estimate. Is it necessarily wrong? So do you think that if, I think Ishra isn't here today, so I'm just gonna say that for the day. If Ishra were in class today, our proportion would be the same?
No.
Why?
If we're more people, it's definitely going to be a different percentage. Like, it's not possible to be the same exact percent.
It's not going to be the same exact percentage because we're going to change both the denominator and the numerator of this fraction, right? So we have no way of knowing if this is going to be, so it's definitely not going to be the same number, and we don't necessarily know if it's going to be a smaller number or a larger number, right? And that would depend on what her answer would be to this question. Does everybody understand that?
Yeah.
Okay. So do you think, next thing, do you think that if we interviewed everyone in Canada, the percentage of teens who met friends online would be exactly 57%?
I feel like it would be less.
It would be less? Okay, why less particularly?
I don't know. I feel like when you have a larger group, like the numbers come closer together.
Okay, but they would come, okay, that's actually a pretty good remark, but the numbers would be closer together to the actual value, and it's not necessarily true that the percentage is smaller than 57%.
Yeah.
Right? So it might get narrower around 57% or around a larger value or around a smaller value.
Okay.
Okay, so chances are the percentage would not be exactly 57%, because if it were exactly 57%, that would just mean we were really, I mean, this research company was really lucky in finding the exact percentage. But chances are, you know, the percentage is going to be somewhere around 57%. but not necessarily exactly 57%. And we have no way of knowing what the exact percentage is going to be unless you interview absolutely everyone in the population, right? So, yeah, that makes sense for everyone. Everybody understands that. Again.
Yeah.
Okay, good. So what we're talking about here is populations and samples. And a population, so I'm just going to define the difference between the two, and then I'm going to talk about different ways that we have of choosing samples, and that's going to be it. And then afterward, you can work with your groups. So you'll have the population of a study are the people, all the people that we want to learn something about. And the sample consists of the people or objects, that are selected from the sample, from the population to be studied. Okay, so it just means population is everyone that I want to study, sample are the people that I'm actually going to study. All right. So in the example that I just gave, what is the population?
Teenagers.
Teenagers in North America, right? So teenagers in North America. What was my sample?
The 1060 kids.
The 1,060 kids between the ages of 13 and 17, right? So this is our population or our sample. Now, why do I choose samples? Why do I have to use samples instead of looking at the population? Yes?
You get a more like specific answer.
Then
like
what?
It's more concentrated than if you would look at the whole population.
So you would look at, yes, you would get results that are a little bit more concentrated than if you look at the whole population. But if what we're trying to learn about, if what we're trying to do is learn something about the whole population, then there should be an advantage to looking at the whole population, right? So if we could, we should be watching the whole population instead of a sample. Why is it not necessarily ideal to look at the whole population?
It would take too long.
It would take too long. What else? So it would take too long. What else? Too much of what else? Take too much time, too much money, right? It would be really, really difficult to call absolutely everyone. It's probably unlikely that we would actually be able to contact absolutely everyone that we would be interested in looking at. And so it couldn't really be feasible. There's like economic concerns, there is feasibility concerns, and so on. So instead, what we do is we study smaller groups of people, and we try to look at what conclusions we can draw from that group of people and see if those can be generalized to the population. Now, in order for our studies from a sample to be able to generalize to a given population, we need to make sure that our sample is good enough. Right? So a good sample would be, first, representative of the population. Right? So what does that mean? It means that it's actually, it represents pretty well the population, right? So if I have a population that is half girls, half boys, and in my sample I have 10% girls and 90% boys, then my sample is not too representative of the population. And so the conclusions that I draw from that sample are not going to be that good. In the same way, my sample needs to be large. So that's something that, I'm not sure who mentioned it earlier, but you said, basically, if the sample is larger, then I trust the results more. And that makes sense, right? If I have a larger sample, then that means that my results were obtained from more information, and so they should be more trustworthy. A sample also has to be practical and economical, which means that I need to have enough resources to actually collect data from the people that I want to collect data from, and I need to have the possibility to get that information. So I need to be able to get to those people. And as much as possible, but here's with an asterisk because this is not necessarily always the case, it's random. Right. And the reason that we would like our samples to be random is that if a sample is random, that means that we are not introducing any biases onto our sample and that the sample is actually a fair representation of the population. Does everybody understand this?
Yep.
Yep. Okay. All right. So
wait.
Yeah.
What would make it practical or economical?
So for example, if you are trying to look at, what can I say? You're trying to poll people about an election, right? So that means you're collecting data on who people are going to vote for in the next election. For it to be practical, it needs to take a short amount of time, because if you try to interview all of your population, then you're going to spend a lot of time. And by the time you get your poll results, the election is going to be done, right?
Okay.
Another idea of making it economical is maybe that, you know, reaching absolutely everybody in your sample would, so that's it. Because, you know, collecting samples is time consuming. Very frequently people are paid specifically to go survey other people, subjects for the sample and so on. And so actual time can be very like it can actually have a monetary cost if you're associating, like if you're paying people to survey other people, then that means that you're going to have to pay them more if they work more, and at some point your resources are going to burn out. Does that make sense?
Yeah.
Yeah. Okay. Good. All right. Good. So then we're going to talk about how to pick a sample. Almost there. So there's a couple of ways of picking samples. The first, and there's two main categories for how to pick a sample. The first possibility is quantitative sampling. And the second option is what we call qualitative sampling. All right, so for quantitative sampling, what that means is that you actually know what the probability of choosing a certain sample is going to be, and you can make sure that, you know, everybody has the same chance of being selected in your sample. So that means everyone has the same probability of being selected. Whereas for qualitative sampling, you don't have a way to verify this. Okay, so sometimes qualitative sampling is just a little bit more feasible, but it has the disadvantage that you can't guarantee that everybody has the same probability of being selected. For quantitative sampling, you will always need a data frame, which is basically a list of your population. Okay, and having a list of your population sounds like an easy problem to have, but it really isn't, right? So for example, if you're looking at a population of everybody in Montreal, it's difficult to figure out a list of absolutely everyone that's living in Montreal, right? So for example, if you go to the phone book, you might have a bunch of people that live in Montreal, but you will only have the people that have a phone book. If you look at, I don't know, records of residents in Montreal, you're going to have a bunch of people that live in Montreal, but you'll also have a bunch of people that moved away and forgot to tell the city that they were not living in Montreal. You might have problems with people that have, I don't know, similar names, or people that have died, and there's things that have not been solved there yet, and so on and so forth, right? So making a list of all the people in your population is not necessarily an easy problem. Now, assuming you have a data frame, there's a couple of ways in which you can do quantitative sampling. So those ways are the first one. Oops. Okay, whatever. So the first way that we can have of selecting a sample is called simple random sample. The simple random sampling. Then we're going to have systematic sample. Then we're going to have stratified samples. And then we're going to have what we call cluster sampling. Okay. So a simple random sample is exactly what it sounds like. So if you have a certain population, which has people that are different in ways. So for example, you could think of a population that has men and women, and you choose things through simple random sampling. That just means you're going to, at random, choose a given sample from your population. Okay, and that will be your sample, and that's going to be it. Does everybody understand that? Yeah, so this is just like what you would imagine. You have a list, you choose at random a certain number of the elements in your list. Then you can have a systematic sample, which is basically, again, assuming that you have a list of everybody in your population. And this population is pretty similar to the one that we have above. So we have this and that. The way that systematic sampling works is that you start at a given point, and then you skip a certain number until you fill your sample, right? So for example, you say, I choose the first one, and then I skip 2, and then I choose the next one. And then I skip 2, and I choose the next one, and I skip 2, and I choose the next one, and I skip 2, and I choose the next one. And this would be my sample, right? So imagine that you have a list. This is exactly the same thing that you would do. You would skip a couple and then go like this. So that might make it easier to do it like practically speaking. Okay, so that's easy. Then a stratified sample is something that comes into play when you want specific populations to be properly represented in your sample. So what's going to happen there is, for example, here I have 9 stars. And I have 6 hearts. And for some reason, I want to make sure that stars and hearts are represented in my sample in a way that is proportional to the representation in the sample. So over here, in the population. So here I have that in my population, I have 60% of the elements that are stars, and 40% of them are hearts. Okay. And so what that means is that if I choose a sample, I need to make sure that this is proportionally represented in my sample. So for example, I'm going to choose 3 elements over here, and I'm going to choose 2 elements from my population of hearts. Oops, maybe like these 2 over here. Okay, and that way I can make sure that my sample is properly represented like that. Does that make sense for everybody? Do I have any questions? No questions, easy. Okay, so then I have the option of cluster sampling. Whoops. And cluster sampling is, for example, again, imagine that you have a city and you want to interview people in your city. Well, instead of, it might be, for example, difficult to get a list of everybody that is in Montreal, but what could be easy to get is a list of all the postal codes that there are in the city of Montreal. Then you could choose a couple of those postal codes, and for each one of the postal codes that you choose, you're going to interview everybody that is within that postal code, right? So for example, in my block of apartments, then everybody will be sampled. So that would mean I have a sample that has a certain number of clusters, and then I'm going to choose a couple of the clusters to be represented in the sample, and everybody in the sample is going to, everybody in the cluster is going to be sampled. Okay. In the cluster sample, you have to be careful because this is going to be a good way of sampling only if all of my clusters are more or less similar to one another, right? If you have reason to believe that in a specific cluster, there's going to be people with specific characteristics, and in other clusters, there's going to be people with very different characteristics, then your sample will no longer be representative of your population. Do I have any questions? No questions, okay. All right, so this is all the ways in which you can have quantitative sampling. And then there are all the possibilities of how we could have qualitative sampling. So there's, again, 4 ways that I'm going to talk about qualitative sampling. And those ways are convenience sampling. Sounds dumb, but it is an actual scientific name for the type of sampling. Voluntary response sampling. Everybody knows what this is. And then, actually, I'm only going to talk about, okay, so I'm going to talk about purposive sample and about snowball sampling. Okay, so inconvenience sampling, what you have is basically that the interviewer is going to ask whoever it is easier to ask questions to, right? So for example, if I stand at the exit of a metro station and there's a bunch of people that are around me and I want to do, I want to choose a sample that is convenient for me, then I am going to go get the people that are probably closer to me, right? So maybe like this will be my sample. Right, so I'm going to have just a sample that is easier to get. Can anybody think of any problems that you could have with this type of sampling?
It's not representative.
It's not necessarily representative, and it depends a lot on the interviewer, right? So maybe without realizing, the interviewer or the person that's sampling has certain biases toward or away from certain populations, which would then be either overrepresented or underrepresented. And so it's important that that you know those judgments don't come into play when you're choosing a sample, because then you will be introducing a bias into your sample. Then there's the possibility that there's voluntary response. So basically what that means is, again, you have somebody that's collecting data, and then you're going to have a bunch of people. And those people, so like, again, some people over here, and then again, those people are going to answer questions, but they are the ones that are going to select to go to the interviewer. Now, can anybody think of any trouble that there might be with this type of sampling? Anyone?
Maybe it's only people who have a certain opinion that will answer.
Okay, so what it does is that's really good. So only people that have, this biases people toward a certain type of answer, right? So for example, if I ask, I don't know, there's this actual famous case where a magazine tried to, a college tried to get back to its alumni and then ended up reporting that the average salary of the alumni from this college was something exorbitant. Let's say like $150,000 per year. And then they published that as if it were a study. And when you dug onto how the sample had been collected, it was a voluntary sample, right? And so what that means is that, okay, well, the people that are going to be pretty comfortable disclosing what their salaries are the people that are going to have high salaries, whereas the people that don't necessarily want to disclose that information are not going to take the time to answer the survey, right? So you're introducing biases in the very way in which you're going to be choosing that sample. Does everybody understand that?
Yep.
Yeah. All right, then you have purposive sampling. And what purposive sampling is that suppose that you have a question that you want to answer, but you know that only a few people in the population have the characteristic that that you are looking to study, right? So that means you have just a couple of people that have a certain category. Then it doesn't really make sense to survey the whole population if you know that only a couple of people are going to have that that characteristic. So you might end up going to get them yourself, right? So that happens when you have small populations of interest. You actually have to go get the people that are within the population. So in this case, it's kind of like you're already targeting a certain kind of bias because you're looking at a very specific population. Is this clear for everyone?
Yeah.
Yeah, okay, good, thank you. Okay. And then for snowball, this is actually just this is for even rarer populations. Suppose that I'm the interviewer and I am looking to study a very, very rare disease. Okay, so I know I'm a doctor and I only know a couple of people that have this very rare disease, but I want to study more people that have this disease. Well, maybe these people, because of support groups or anything like that, know other people that also have this very rare disease, and they can refer them to me, right? So in that case, we talk about snowball sampling, because each one of the people that you have is going to maybe refer you to new people that you can interview, right? So you'll have something like this. Does that make sense for everybody? Yeah, so this is for very, very targeted populations. Is that okay? All right. So I have added on. I've added on Leah an assignment, a homework that says something like homework research project or create your own survey.
Wait, miss.
Yeah.
I was writing down the other ones and I didn't catch snowball.
Snowball just means that you are targeting a very, very small population, which means that you're going to need some kind of like link to the people, because it's a population that is difficult to reach. You're going to reach a couple of people that will then reach a couple of people, and so on and so forth, so that the links are done through the same people that that participated in your survey originally. Does that make sense?
Is there like an example?
So imagine that you're looking at I don't know, a population of a very, yeah, like the example that I gave is like if you're studying, I don't know, the psychological effects of a given disease on people, and it's a very, very, very rare disease. Maybe you know a couple of people that have this disease, but if you just send a broad call out, only a couple of people will reply. Yeah. Mm-hmm. If those two people reply, but then those two people know themselves a couple of people that have the same disease, then they can refer those new people to you. And then those two new people might refer some other people to you, right? So you're just kind of connecting on those things. Okay?
Yeah.
Okay. So, yeah, okay, there you go. And I have Johanna, Phil, Shauna, and Michaela in the same one. And Victoria. Yeah, okay. All right. Now, in Leah, there is a new assignment that is called like create your own survey or something like that. Collected data. I don't know what I called it. The very last assignment the very last document that I logged on. Where is it? It's called Design a Study. Okay. I'm going to open rooms with all of your teammates, so you're going to be able to talk to one another. And you'll have to talk to your teams and come up with a couple of survey questions and a couple and a method by which you will collect information. Does that make sense for everybody?
You need to write it down.
Sorry?
You need to write it down and hand it in.
You'll hand it in, but on Tuesday. Okay, so if you want to keep working on it afterward as a group, you can do it. If not, then you can submit whatever you have today. But it's going to be a good start, because on Tuesday I am introducing the research project for the semester, which is going to be very heavy on the research part, and so it's going to be good practice for that second part.
Okay.
Right. So I've created rooms, breakout rooms. Does everybody have access to them?
Yeah, I see it on the bottom line.
Okay, good. So breakout rooms, I can see that some people are already, I think you can join the group that I assigned to you. There you go.